Alright, so we're going to go through these relatively quick. You're not going to have an assignment on Unit 4 through 7, I believe it is. Well, actually, the first one's going to be Unit 8. So, real quick, we're going to go through sketching. Sketching straight lines. Most industrial drawings are made in a drafting room using drafting equipment or computer-aided drafting and design systems. The finished drawings provide detailed information needed to make an object. Many designs, however, often start with a shop sketch, like shown here. A shop sketch is a freehand drawing of an object. Freehand drawings are made without aid of drawing instruments, drafting machines, or computers. Shop sketching is often a very important step in the development of an idea. Shop sketches may be prepared by anyone who needs to communicate an idea in the picture form. Engineers, toolmakers, technicians, designers, drafters, or other skilled workers frequently use sketches. So equipment. Shop sketches requires very little in that way of equipment. The only materials are needed is a pencil, an eraser, and paper. The pencil is used to have soft lead such as number 2 or HB grade. Soft lead makes darker sketch lines. The paper used should be a grid type. Figure 4.2 uses grid paper. Helps keep the sketch in proper proportions and is very helpful for a beginner. An experienced or accomplished sketcher may use unlined paper or sketching. Sketching straight lines. The basic straight lines used in sketching a horizontal, vertical, or inclined lines. And horizontals are stretched from left to right between 2 points. This type of line should be drawn with the movement of a forearm across paper. To stretch this line, lay out 2 points of distance apart. Lightly sketch the line between 2 points, and then darken the lines with a proper weight. Vertical lines are stretched from top to bottom between points. The same procedure is used as described in horizontal lines. Start at the top point and slowly pull your arm backwards to the bottom point. Inclined lines are slanted or sketched lines with the same movement as horizontal or vertical lines. Once the proper angle is determined, a point may be marked off. The line may then lightly be sketched. A suggestion for sketching inclined lines is to turn the paper so that the line may be drawn horizontally. Figure 4.3 shows 3 basic lines. You can actually do this in your book if you actually bought it, and sketch that actual print there. Unit 5, sketching curved lines. Introductions. Circle, arcs, and ellipses are the most common curved lines that must be sketched. These types of lines are more difficult to draw accurately and require practice. This unit describes some common methods to use to sketch curved lines. Circles. There is more than one method for sketching circles. Each method uses an aid to help keep the circle in a true size. Perhaps the most common practice for sketching circles is the square box method. This involves scribing a circle in a square that is proper size for diameter of a circle. Figure 5.1 shows a proper sketch in sketching a circle. So 1, determine the location of the center of the circle. Lightly draw the center lines of the circle. Mark off the radii of the circle to each center line. Lightly sketch a square the same diameter as the circle. And starting at an intersection of the center line of the square, sketch the circle. So step 1, step 2, step 3, step 4, and then step 5. An arc is a part of a circle. This method of sketching an arc is similar to the use of a circle. So determine the location of the arc, lightly draw the center lines of the arc, mark off the arc radius, square off the area between center lines, and then sketch the arc required. An ellipse is a oblong looking circle. The method used to sketch an ellipse is called a rectangular method. So 1, determine the location of the center of the ellipse, lightly draw the center lines of the ellipse, mark off the major axes of the ellipse of the horizontal center line, mark off the minor axis of the vertical center line, lightly sketch the rectangle through the points of the center lines, and then sketch the ellipse inside the rectangle. 1, step 2, step 3 and 4, step 5, and then step 6. And then using center lines, provide the following grid, sketch the spacer as shown. So that would be another assignment you could do on your own. Alright, Unit 6. To describe an object with both straight and curved surfaces requires sketching combinations of lines. The principles used in Units 4 and 5 should be applied to combination sketching. So parts with straight surfaces frequently have rounded corners. To remove sharp edges to provide strength. An outside rounded corner is called a radius or a round. The inside rounded corner is called a fillet. Figure 6.1 describes the steps required to sketch a fillet or round. The procedure is basically the same as described in Unit 5 for sketching arcs. However, the application here is used to connect two straight surfaces. Parts such as connecting rods, indexing arms, flanges, and brackets have slight surfaces of cylindrical surface. A typical sketch often requires drawing combinations of lines to describe these parts. A good example is the shape description of an open-ended adjustable wrench. This type of tool has straight surfaces, curved surfaces, and radii. And there's a picture of it. Figure 6.3 shows a working drawing for a connecting rod. Figure 6.4 shows the proper steps to connect the cylindrical and flat surfaces. 1. Lay out the center lines for each cylindrical diameter. Lay out the radii of each diameter of the center lines. Box the circular portions of the connecting rod. Sketch the cylindrical ends of the rod and connect the straight lines. So step 1, step 2, step 3, and step 4. Using center lines provided in the following grid, sketch the gasket shown. There's another one that y'all can do on your own. Unit 7, Introduction. Industrial drawings are representations of three-dimensional objects drawn on a flat plane. The print reader must observe the drawing and interpret the true size, shape, and function of the object. The ability to visualize an object accurately can be simplified by drawing an observer with a pictorial sketch of the part. In a pictorial view, called an isometric representation, the object is rotated around one or more axes to show combinations of surfaces in one view. This allows individuals with limited technical drawing to interpret the shape of the object. So, isometric projection is the most frequently used class of the pictorial sketch and has been used exclusively on the drawings in this text. The object sketched in the isometric provide a description view of more than one surface. In the isometric drawings, the three principal angles are of equal size. Additionally, the three principal surfaces are equally inclined to the plane projection. True isometric projections must be drawn using special isometric scale that is 2/3 the full size. The angle and inclination is the isometric requires projection to be drawn are less than true size. Generally, however, when a sketch is isometric, the 2/3 size rule is disregarded and the principal surfaces are drawn full scale. It is the full scale representation together with equal angular axes that make isometric projection preferable over other types of axiometric representations. The true shape of and size of the whole cannot be represented accurately on an isometric drawing. The surfaces are inclined to a plane of projection and the whole is shown as ellipses. So there's a picture of that. Oblique projection. Oblique projection is an isometric projection that places the object in such a manner that more than one surface is shown in a single view. In the oblique drawing, however, the object is placed with one principal face parallel to the plane projection. The lines that recede this principal face may be drawn at a convenient angle. Generally, a 45-degree angle is used. The angle selected often depends on whether a greater or smaller angle will best show features that appear on receding surfaces. The lengths of the receding lines of an oblique drawings are most frequently shown on full scale. This, however, leads to some visual distortion of the true size of the object. The degree of distortion may be limited by shortening the length of the receding surfaces to any amount selected. And that kind of shows you what it's meaning there. An advantage of oblique drawing is that all features in the principal surface may be drawn into true size and true shape. Therefore, the whole drawing in oblique appear as circles in principal surface. And then they're showing you another thing to use that you could do on your own. Alright, we're going to do Unit 8 in another another video just by itself. It'll be short, but I've only got a few minutes left on this video, and I'll start the next one in a minute. Thank you.